Great, so welcome to grade 7 math. We are now looking at chapter 2.1, which is on similar figures. And what I'd like you to do is take your graph paper out or your grid paper and um, make two axes. So using a ruler and a pencil, make two axes, like an x and a y axis. And then what I want you to do is take your ruler and draw a line that that shows a rectangle that is 3 blocks wide and 2 blocks tall. So, for example, that looks like this. And then what I want you to do is continue that straight line all the way across diagonally. What you're basically doing is you're taking a straight line and seeing that it's a relationship between the x and the y axis. It's a straight line, so that for every time the x goes up, the y is also going to go up a certain amount. So we have this kind of rectangle, and then continue that line out and see what other rectangles, what other points along this grid you're also going to intersect. So we have that this rectangle is a 3 by 2 rectangle. We always start with the x-axis first, so the width first before the height. And then if you continue on, try to find other rectangles or other points along this grid that have the same that intersect that line as well. So pause the video now, continue the line, and see if you can find other rectangles. When you continue going on, you'll see that it intersects at a couple of other points. It intersects here, here, and here. So it makes a straight line that goes all the way across the Cartesian grid. And so the other kind of dimensions that would fit are a 6 by 4, and then a 9 by 6, 12 by 8, and the last one we have here is a 15 by 10 rectangle. So if we look at all these pairs, we could try to see if there's a pattern here. So according to our length, or our kind of width, and then our height, we see that the coordinates, or the pairs 3, 2, 6, 4, 9, 6, 12, 8, and 15, 10, we could try to see a relationship between these numbers. So for example, from 3 to 6 and from 2 to 4, is there a relationship between the two? Then you can see it's either plus 3, but on this side it's plus 2. So that doesn't kind of balance. But if you look at another relationship, or another kind of way of getting from one number to the next, you could multiply by 2, and you can multiply by 2 on the other side as well. For 3 to 9, you multiply by 3, and on this side you multiply by 3. So notice that proportions, or ratios, balance through multiplication and division, and not through addition. So that means if we're looking at two things that are the same, or two things that are different, in terms of its similarity, then we would have to multiply the sides rather than divide the sides, rather than add the sides. So if I take an example of this koala bear, and let's just plop them in to here. If we take the koala bear and we just add to one side but not to the other side, notice what happens is that it gets a little distorted. Or if I kind of move it in a direction, I move it a little bit up like this, and then I add just a little bit on the side, it doesn't look exactly the same. What I have to do is I have to multiply both sides by the same amount. And then what happens is the proportion stays the same, so that the koala bear still looks like the same type of koala bear, and not not a squished version, or not a skinny version of the koala bear. So let's take another example and let's solve a problem. If I have a photo is 6 inches by 4 inches, a photo 6 inches by 4 inches, I would like to increase the width to 18 inches. How tall would the photo be? We're going to assume that we keep the same proportions and we're not going to squish it, because we could just increase the width of this koala bear and make it a very squished koala bear, but we want to assume that it's the same proportions. So that means 6 by 4, where 6 is the width and 4 is the height. And I want to make it to a width of 18 inches. How tall will it be? Well, if I compare it from the original one, 6 inches was the width originally, and how do I get from 6 to 18? Instead of adding, I'm not going to add, I need to multiply, because of proportion or ratio, I need to look at the multiplication of it. So in this case, I need to multiply by 3 in order to get 18. In the other way, I need to multiply by height, also by 3, in order to get the final answer. That means the height of the final photo will be 4 inches times 3 equals 12 inches. This times 3 is what we call a scale factor. Scale because it means it needs to keep it in proportion, and factor because, as we saw in chapter 1, it's something you multiply by to get a larger number. So hopefully you understand what a proportion is, that it's a number sentence that shows equivalent ratios, and that they only balance through multiplication and not through addition. And that in finding a scale factor, when you use scale factors, you can find unknown proportions, and you can solve those unknown proportions using the scale factors. Hopefully you understood the lesson.